Welcome again, Wildcats. All right, so today we're looking at Friday, February 10th, and we're going to look at rational function inverses. And that's going to be on page 55. So let me give you again the warning here. Again, I'm not here. I think y'all probably noticed that by now. So you might, I don't know, last video was 24 minutes and like 48 seconds. I think this one might be about the same length. I think it's a little bit shorter. The inverse function times it's more straightforward, I guess. It's not as long of work. So, but again, it might go long. So if you think that's too long, go ahead and watch the video in class and then you can complete that, okay? And again, since I am not here, I'm going to actually go through all the examples in the video, all right? So I'm assuming now that you have your table of contents updated. So now let's take a look at our notes. All right, so if you notice, almost got it all onto the screen. All right, so we're looking at rational function inverses on page 55, and I'm hoping you notice that the inverse rules still apply, and they apply the same way to all the functions, okay? So there's still 4 ways to find the inverse, okay? Number 1, to graph. You're going to reflect over the y equals x line. Now, we're actually not going to draw the y equals x line, though, because before making this video, I actually worked example 1, and I noticed it just, you wouldn't even see the y equals x line if you graphed. There's just too much. There's asymptotes, there's a graph, there's just too much going on, okay? But if you did, it would reflect the y equals x line, okay? Number 2, using the table, you switch the x and y. Number 3, it's algebraic, and you switch the x and y and resolve for y. So if you would, pause the video and update the first 3 ways. All right. Now, the next is composition of functions, okay? So we're going to write it down because it still applies to this, but we're actually not going to do it in the lesson or the examples because the algebra is just crazy. And I think it's better left for a later date, maybe when you're in pre-cal or calculus or in college, okay? But if you just are bored and you want to find out if it actually works, you can actually use composition functions to see if they're inverses, okay? Which could be fun. All right, so we know that when f of g of x is equal to x and g of f of x is equal to x, then they're inverses. So when the result of f of g and g of f is x, then f of x and g of x are inverses. Okay, so pause the video and update that. All right, now the next part is a couple notes. Is that we said before that when you do the inverse, the domain range will switch. But here with rational functions, when you do the inverse, the asymptotes will switch. Okay, so if you would finish those notes up. All right, now let's take a look at our examples. All right, example number 1. Okay, so I'm going to graph the inverse. Now first, you want to color code the inverses. So what I've done for you is I've already graphed f of x equals 1/2 x plus 2. Okay, so it shows up, it looks like blue, but I'm using purple, but I'm actually going to color code the original function. Okay, now to find the inverse, you need points. Now we know that you only get 1 good or 2 good points, okay, with rational function. So we know we can, here we get to the right one up 2, so one of those points is 1, 2, and the other point is, oh, wait a second, let me double check. Ooh, hold on. 1, 2, 3. It's actually 1, 3. And then here it's -1, 1. Okay. And let me double check that. I'm pretty sure that's the origin. Yep. All right. So we know that here our asymptotes are x equals 0 and y equals 2. Okay. So now to do the inverse, we switch to x and y, and you switch the asymptotes. So our new x and y are 3, 1, and 1, negative 1. And our new asymptotes are x equals 2 and y equals 0. All right, so, and I'm actually going to do the new asymptotes in black so that you don't confuse the asymptotes and the function. Okay, so our new asymptotes are x equals 2 and our y equals 0. You don't need to graph the original asymptotes, just the new ones. Otherwise, it just gets way too much on the graph. All right, so, but you need the asymptotes because it's from the asymptotes where you move. Okay, well, actually, no, in this case, you don't actually have to move because you actually have the point. So we go to the right, 1, 2, 3, up 1. Now, we know that we fall along the vertical asymptote and move towards the horizontal asymptote, but never touch. Okay, and then we go to the point 1, negative 1. And again, you fall along the horizontal asymptote and move towards the vertical asymptote, but never touch. All right, so when it asks for the asymptotes, I actually want you to give both. So, and this is where the color coding is important. So mine, I think it's showing up in blue, but I'm using purple. Are x equals 0, y equals 2. And the inverse are x equals 2, y equals 0. And I want you to do that so you can see that the asymptotes switched. All right, so finish up example number 1. Now, what I'd like you to do is pause the video, and I want you to try example 2 on your own, okay? All right, so pause the video now. All right, so I'm assuming you pause the video, and you've already tried example 2. Now you're going to follow along with me and see if you're correct. All right, so again, you're going to color code. So I'm going to put the original function. I'm using purple, but I think it looks blue. But then again, everything to me looks blue. So I'm going to trace those. Now, I've saved some time, and I've already graphed f of x equals 1 divided by x plus 2 minus 3. All right, and it looks like our asymptotes, our vertical asymptote is x equals negative 1, negative 2. And our horizontal asymptote is negative 1, 2, negative 3. Now you're like probably asking me, so how do you find the asymptotes? Well, what I'm looking for is where the graph doesn't touch. And if you have trouble seeing it on the paper, you might graph it on Desmos, but you can see that they don't touch at x equals negative 2 and y equals negative 3. And like I said, it's all harder to see on the paper, but if you graph this on Desmos, you'll see it much clearer. All right? Now, we need our points. So it looks like we go left, negative 1, 2. So negative 1, 2 is a point. Ooh, negative 1, negative 2. Almost made a mistake. 1, 2. Okay. And then we go left 1, 2, 3, negative 3. 1, 2, 3, 4. So negative 3, negative 4. All right. So now to do the inverse, all we do is switch the x and y and switch the asymptotes. So x, y. So that's negative 2, negative 4, negative 1, negative 3. And our new asymptotes are x equals negative 3 and y equals negative 2. So x equals negative 3. So 1, 2, let's see, negative 1, 2, 3. And y equals negative 2. So 1, 2. See. So y equals negative 2. All right, so our new points are to the left, 1, 2, down 1. And again, we follow follow there, never touch. And then we go negative 4, so negative 1, 2, 3, 4, down 1, 2, 3. All right, so there's your inverse. So for our asymptotes are x equals negative 2, y equals negative 3, and x equals negative 3, and y equals negative 2. All right, so finish up example 2. All right, let's look at example 3. All right, so inverse inverses. Again, f of x, we change the y, and then we switch x and y. So x equals 1 divided by y minus 2 plus 3. We subtract 3 from both sides, we get x minus 3 equals 1 divided by y minus 2. Now at this point, you probably want to put both of these in parentheses and divide this by 1. Okay, so you're going to cross multiply, so 1 times 1 is 1, and then x minus 3 times y minus 2. You're going to divide both sides by x minus 3, so you get 1 divided by x minus 3 equals y minus 2. Add 2 to both sides, so y equals 1 divided by x minus 3 plus 2. Now, what I want you to look at is the original function and its inverse. And I want you to see if something happened, if you notice something. And then I want to ask yourself that question at the end of the assignment, does that always happen? Okay? So if you look closely, something happened, okay, between these two. And I want you to ask yourself, is that going to happen for every one of them? Okay, then the other thing is, what I would like you to do is pause this video, and then what I want you to do is work example 4, 5, and 6 on your own. And then once you've worked them, unpause the video, and then see if your work matches my work. Okay, so pause the video now. All right, so at this point, I'm assuming you paused the video. So now let's see if you were correct. All right, so we're going to change f of x to y, and then switch x and y. So x equals negative 1 divided by 2y. We put a 1 under the x, and we're going to cross multiply. So 1 times negative 1 is negative 1. And then 2y times x is 2yx. Okay, so now we're going to divide x by both sides. So you get negative 1 divided by x equals 2y. And then this is about to hold your breath because this is going to be crazy. Okay, then we're going to divide both sides by 2. Okay. Well, anything divided by itself is 1, but here's the thing. Technically, that's actually divided by 2 over 1. Okay. Now, when you divide fractions, you flip the denominator and multiply. So this becomes y equals negative 1x times 1 divided by 2. So when you divide by fractions, you flip the denominator and then multiply it by the numerator. Okay? And I say that because technically, even though it's fractions, there's your numerator, there's your denominator. So that equals negative 1 divided by 2x. So at this point, if you're like, whoa, Mr. Luke, what just happened? You might pause the video and open a tab and do some research on, maybe find some YouTube videos about dividing by fractions, okay? All right, so let's look at example 5. All right, example 5. So change f of x to y, okay? And I said YouTube dividing fractions by fractions. There you go, divide fractions by fractions. All right, so change f of x to y, and then switch x and y. So x equals 1 divided by y plus 4. All right, so you're going to subtract 4 from both sides. You get x minus 4 equals 1 divided by y. I'm going to divide this by 1 so I can cross multiply. So I get, and I'm also going to put this in parentheses. So y times x minus 4 is y times x minus 4 equals 1 times 1 is 1. You're going to divide both sides by x minus 4. So y equals 1 divided by x minus 4. All right. Last one. All right, so let's look at example 6. All right, so you're going to change f of x to y. Okay, so then y equals, so then you get x equals, okay, so then negative 1 divided by 2 parentheses y plus 4. Okay. All right, so we're going to cross multiply, so you get 2 parentheses y plus 4 times x equals negative 1. Now, in multiplication, I can rearrange the order, so I'm actually going to write this as 2x y plus 4 equals negative 1. Then I'm going to divide both sides by 2x. So you get y plus 4 equals negative 1 divided by 2x. And then we're going to subtract 4 from both sides. So y equals negative 1 divided by 2x minus 4. All right, so there you go. That gets you through examples. All right, so that should get you to the class. Now, here's something I was thinking about since it's flipped classroom. Now I'm going to be gone, so I can't really help you on Thursday and Friday. And if there's a problem that gets you so frustrated, like, oh my gosh, like I said, I monitor my emails quite often, and so you can email me, say, hey, Mr. Luke, can you explain one of the problems? And I'm actually going to bring my camera, my Chromebook, all of it with me, so I could actually get your email, give me a couple hours, I can sit down and I can actually work that specific problem for you. And in the YouTube, I'd like label it whatever the assignment day and then problem number, so I can explain it to you. So something to think about. I think I've explained it pretty well, but if there's something that you want me to explain on the assignment, let me know. Okay. So with that, have a wonderful Wildcat weekend.